Okay, so we're going for question 4. This is a little bit on limiting reactant. Take a look here, as well as percentage yield. So let's get started. So for this kind of stoichiometry question, that comes with a little bit of context as well as balance equation in the middle, take some time to appreciate what's the information given first. Okay, so they tell us there's 0.05 mole of MgCO3, which is this, as well as 0.08 mole of HCl, and they want you to prove that MgCO3 is actually in excess. So I'm going to use everything in MgCO3 in rate. Okay, so it's a 2-mark question. Don't overthink it. And the best part about this question is, see, they actually have given us in moles, so it's technically really easy. So what's the first step here is you do need to, I'm just going to use blue here, you need to compare HCl with MgCO3. Okay, and how do we do that is we use the stoichiometry, basically the number before, I'm going to use green, rate, okay, the number before the formula. Okay, so if you look at MgCO3 from the balance equation, there's no number right in front of it. What it means is it's just simply 1. Okay, and if you look at HCl, you actually have the value of 2 here. So where do I get this 2:1? Again, it is from the balance equation over here and over here. All right, no number means it's the stoichiometry is 1. Just 1 mole of MgCO3 reacts with 2 mole of HCl. That basically is what it means. Okay, so from my question, okay, we're going to choose one at a time. So we just focus on HCl first. Okay, what it means is from question, if you are given 0.08 mole of HCl, you need to find out how many mole of MgCO3 is actually required. Since the ratio is 2:1, that means I will only need half of 0.08. That means I only need 0.04 mole of MgCO3 is needed. However, I'm actually given 0.05 mole of MgCO3, right? So since 0.05 is more than 0.04, this is given, and this is actually what you need, right? Therefore, MgCO3 is in excess. That's all. That's all you need to do. Okay? Sometimes a more complex question will look like this. Instead of giving you like a mole, they'll give you like 0.08 grams. Okay, and what do you need to do? Usually then this will be like a 3-mark question. So the first that you need to do is to convert to mole first. And the converting to mole is always using this simple triangle: mole, mass, AR or MR. Okay, and I can't emphasize this enough. And if you have heard me say this like 3,000 times, which I think you have if you keep following my video, this would be from the periodic table. Okay, so that's usually a more complex question. They give you mass instead of mole, but for any mole concept question, if you ever start convert things to mole first, maybe they'll get an engine running and you start recalling this triangle and you start remembering, comparing the mole concept here, the mole ratio here, and then you move on to whatever the question need you to find. Okay, so with that, let's move on to the second part of the question, which is percentage yield. So percentage yield has a very standard let me just see, formula. Percentage yield here is equals to actual over theoretical yield, and then you multiply the whole thing by 100%. Okay, so again, let's take some time to appreciate the question here. The question say a yield of 5.5 is actually obtained. This is actually our actual. Okay, so we have got 5.5 on the top, but they did not give us anything about the theoretical. So what we need to do is, we have some information on the top here. We've got 0.05 mole of Mg reacts. Okay, so and then there's excess HCl, so we don't need to worry about HCl. So we want to use this to calculate the theoretical yield of MgCO3. Okay, we want to calculate the theoretical yield of the product form, which is MgCl2 6H2O based on this. Okay, so this is actually our limiting in this part of the question. So because we only have this amount of MgCO3 being given, okay, so we will base our theoretical yield on that. Whatever is formed is based on the limiting reactant. The limiting reactant always stop us from producing more of the product. In this case, the product is this. Okay, so how do we do this? So theoretical yield, it's so again, theoretical yield is mass, right? Technically it's mass, so it's you need to find mole, which is given to us, multiply by the MR of this entire thing. Okay, so we need to use our periodic table. Mg is 24, 2 chlorine is 71, and then I've got 6 mole of water. Every water is 18, so it's 6 times 18. You end up with 203. Sorry, 203 here, and then you multiply by the number of mole. I'm gonna take this away. Oops, take my eraser is too chubby. Okay, and I'll get a mass of 10.5 gram. Okay, and if you sub it into this equation, your actual is 5.5, your theoretical is 10.5 over 100%. Okay, one way to always check that you're on the right track is your actual can never be more than the theoretical. Theoretical basically means if 100% of the reactant reacts, you will actually get that 100% of product. But in reality, it's quite impossible. And therefore, you see, there's actually part 3 to this question. So if we input our value in our formula, and then we multiply it by 100%, you will actually get a value of 54.187%. But if the question don't state, always remember 3SF is what we want. So it is 54.2%. Okay, 3SF, take note, unless the question has another demand like give 4 decimal point, then you follow accordingly. Okay, last part of the question is more of a theory. N is quite popular, so in this case it's 1 mark, but I'll give you at least 2 possible reasons. So one of the possible reasons why we are not able to get 100% yield is because the starting reactant, in this case MgCO3, is impure. Okay, if our starting reactant is impure, you cannot expect 100% production, right? So this is our starting reactant. We start with this, and if it's impure, we can't get more out of it. Okay, another possible reason is it's quite difficult for you to appreciate this if you don't understand that this is water of crystallization. So to produce this product, we need it to undergo that process of crystallization. So you need to think about what could possibly go wrong during the process of crystallization. Here it could be crystals was not allowed to cool long enough. I wanted to write the short form for crystallization to take place. Okay, so these are the possible reasons, but of course, if it's only 1 mark, I would strongly recommend you to just write down that the starting reactant is impure. Alright, I hope this has helped you. Okay, see you around. Bye.